Hello, welcome to ATI 4640. In this lecture, we are going to address forecasting, which drives many other operations and management decisions. Forecasting the demand will assist in inventory management, supply chain management, location selection, and many other decisions. This session and the next session will go over some of the methods and techniques used for forecasting. This session will address the qualitative techniques, the time series techniques of simple moving average, weighted moving average, and simple exponential smoothing, and the forecast error measurements of MAD, MSE, and possibly MAPE. And when we get to that, you will know the abbreviation for each one of them, what does it mean, and how we're going to use it. Forecasting is the basis of all business decisions such as production, inventory, personnel, and facilities. If you need to expand your production, you need to forecast. You need to know what's going to happen in the future. So you forecast or you try to know what's going on. Inventory. If you would like to increase the inventory or decrease inventory, you need to know what's going to happen in the future. Personnel, you need to hire people or to lay off people. You need to know what's going to happen in the future. And facilities, if you need to buy facilities, rent, or expand, then you need to know what's going to happen in the future. So basically, forecasting is the process of predicting what's going to happen in each area and how would that impact profit, sales, cost, and competition. The forecast can be within a short period of time, which is called short range forecast. It can also be medium and it can be long range. For the short range can be from 0 up to 1 year. The medium from 1 to 3, and the long one will be more than 3 years. Examples of short-range forecasting will be purchasing, job scheduling, workforce levels, job assignments, production levels. And examples of medium forecasting will be budgeting and sales and production planning. Examples of a long-range forecasting will be the forecasting of a new product, planning, facility, location, and research and development. Looking at some of the differences between short, medium, and long, the medium and long range forecast deals with more comprehensive issues and support management decisions regarding planning and decisions related to products, facilities, and processes. The short-term forecasting usually employs different methodologies than longer-term forecasting, and the short-term forecast tend to be more accurate than the longer term forecasts. For example, if we take a look at the product life cycle, introduction, growth, maturity, decline, the introduction and growth requires longer forecast than the maturity and decline phases. In the introduction and growth, the firm will be forecasting how to introduce the new product, what will be the reaction of the consumer, how much sales would there be a demand for that product, the new product, and how would the demand grow. As a product advances through its life cycle, forecasting will be predicting personnel, their skills, inventory levels, and the factory capacity. So if you look at the product life cycle and the different phases, you can see that forecasting is critical in the growth phase to make sure the product will compete in the global market. There are three types of forecasts: the economic, the technological, and demand forecasts. The economic forecast or forecasts are used to predict inflation rate, money supplies, and other planning indicators, while technological forecasts are concerned of predicting rates of technological progress, which can result the creation or development of a new product or products. The demand forecasts predict the demand for goods or services and focus on rapidly in identifying and tracking customer desire. Um, Remember the importance of forecasting demand on supply chain management, inventory management, and uh, other areas as mentioned before. Let's look at the impact of product forecast on the following three major areas: human resource, capacity, and supply chain management. In the human resources, forecasting will affect the rate of hiring, training, laying off workers, while forecasting capacity will prevent shortage in inventory level. The shortage can result in undependable delivery, loss of customers, and loss of market share. And in the supply chain management, predicting and forecasting supplier behavior in a supply chain can create good supplier relationships and price advance. Forecasting follows 7 basic steps. The first step is to determine what are we going to use the forecast for. For example, Disney uses park attendance forecast to drive decisions about staffing, opening times, ride availability, and food supplies. The second step will be to select the items to be forecasted. For example, to forecast park attendance, we count the daily number of people coming to all parks. The third step is to determine the time horizon of the forecast. Would it be short, medium, or long term? For example, Disney has daily forecasts, weekly forecasts, monthly forecasts, annual forecasts, and 5-year forecasts. The fourth step is to select the forecasting model, which might depend on the collected data or expert judgment or qualitative data. For example, Disney uses the collected statistical data and use statistical forecasting models. Other models can be used. The statistical models are the mostly used, but other models can be used in Disney as needed. The fifth step is to gather data needed to make the forecast. The sixth step is to use the model or models to make the forecast, in other words, to get the results. In the last step, the results will be validated to make sure of their accuracy, then implemented through making the proper decision. For example, hiring people and assigning different schedules. Forecasts are rarely perfect. Outside factors involved in the forecast, and that cannot be predicted or unknown if we have something that that's impacting the forecast and that is unknown, and it might impact the outcome of the forecast if it's again outside or unknown. Most forecasting techniques assume an underlying stability in the system. Consequently, some firms automate their prediction using computerized forecasting software, then monitor irregular stuff that will happen in the software to make sure that or to understand why these happening. And then we have product family and aggregates forecasts that are more accurate than individual product forecasts. Let's look at some of the forecasting approaches. We have the qualitative methods, which is used when a situation is vague and little data exists, such as new product or new technology. It involves intuition, experience, for example, forecasting sales on internet. Another approach will be quantitative methods, which is used when situations is stable and historical data exist, such as using quantitative methods for existing products or current technology. This approach involves mathematical techniques and statistical analysis, including uncertainty and risks, such as forecasting sales of organic or quantum LED TV. We have OLED or QLED television. This slide and the next slide shows some of the methods used in the quantitative approach. More will be explained in the next few slides. So for the first one is jury of executive opinion, which is opinions of high-level executives, sometimes strengthened by statistical models the executive learned or used from past experience. Delphi methods or Delphi method, which uses a panel of experts and document the most common opinion. Usually they take the average for that one. Salesforce Composite, and those are estimates from individual salespersons that are reviewed for practicality, then aggregated. And then the last one is Consumer Market Survey, which collects customer feedback through surveys and questionnaires. The jury of executive opinion involves opinions of small group of high-level executives, sometimes beefed up by statistical models. The group estimates demand by working together. This method combines managerial experience with the statistical models that we talked about. We said that they will come with experience and maybe they use some statistical models previously, so they will use that to get their estimates or to decide their estimates. It's relatively quick compared to other methods. The Delphi methods follows an iterative group process that continues until consensus is reached. In the group, we have three types of participants. We have the decision makers, the staff, and the respondents. The decision makers evaluate response and make decisions, while staff usually administrates the surveys. And of course, responders are the people that can make valuable judgment, which can be forwarded to the decision makers. The third qualitative method is Salesforce Composite, which each salesperson projects his or her own sales. The sales will be combined at district and national levels. Since sales representative interacts directly with customers, they know what a customer wants. The problem with this method that tends to be overly optimistic, and the sales might be inflated by the salesperson or the district while it's not. Fourth method is the market survey, which asks customers about purchasing plans useful for demand and product design and planning. And they ask on what consumers say and what they actually do may be different. For the quantitative approach, there are 5 common methods that can be recognized: naive approach, moving averages, exponential smoothing, trend projection. All these models are considered time series models that assume that the future as a function of the past. And the last method is linear regression, which takes into consideration other factors that might affect the forecast. Time series models predict on the assumption that the future is a function of the past and present will continue influencing the future. It's a set of evenly spaced numerical data obtained by observing response variable at regular time periods. A time series has 4 components: the trend, the seasonality, the cycles, and random. Trend is the gradual upwards or downwards movement of data over time. For example, the change of income, which should be moving um, gradually upward. Seasonal is the data pattern that repeats itself after a period of time, like days, weeks, months, or quarters. Cycles are patterns in the data that occur every several years, such as political events, for example. Random variation is the data that are caused by unusual situations. This graph represents the demand for a product or service versus time in years. Through analyzing the graph, you can see we can identify all four components of the demand. We can see the trend, we can see the actual demand, we can see the random variation, we can see the seasonal, and we can see the cycle. The trend component is persistent overall upwards or downwards pattern, such as change in income, population, age distribution, or cultural views, and typically will show over several years duration. The seasonality is a data pattern that repeats itself after a period of days, weeks, months, or quarters. For example, restaurants experience weekly seasonal pattern, with Saturday being the peak of the business. Other seasonal patterns could be related to weather or to events such as the football, baseball, basketball seasons. Those are considered seasonal factors or seasonal patterns that affect the demand. And we have the seasonal component that has regular pattern of up and down fluctuations. These patterns occur within a single year. The cyclical component are patterns in the data that occur every several years. Predicting business cycles is difficult because it might be affected by political events, economical changes, or other related factors. It will be noticed over a large period of time. The random variations are glitches in the data caused by change or chance and unusual situations. They follow no obvious patterns, so they cannot be predicted as we need it. The naive approach is the first approach of the time series and is the simplest approach to forecast, through assuming that demand in the next period will equal to demand in the most recent period. For example, if the sales of last month were 68 cell phones, then the sales for this month will be 68 cell phones. Just as simple as that. For some products, this approach might work and be cost effective, and it could provide a starting point for other approaches. A moving average approach uses a number of historical data or actual data values to generate a forecast. Moving average forecast is useful if we can assume that market demand will stay steady over time. A 4-month average moving average is found by simply dividing the sum of demands during the 4 past months by 4 number of months, and the results will be the forecasted or the forecast of the coming month. This example or the example in this slide shows or explains how the moving average forecast works. The example is using the 3 months moving average. So we said 4 months, we can use 3 months, 5 months, whatever. But this one is using the 3 months average. So if we were to forecast the sales in April, we add sales from January, February, March, then divide them by 3. If you look at the forecast or the actual, we can see that we have 10, 12, and 13. So you add 10 plus 12 plus 13, and we divide by 3, and that will give me the forecast for April, which is 11 and 2/3. Although the prediction was around 2, the actual was 16. I mean, the prediction was around 12, and the actual was 16. You can continue using the same approach for other months, and you can see that they can get close at a certain point. So the difference, yeah, there is a difference, but sometimes the difference is not that much. The difference will be not that much. When we have trends, then we can use weighted moving average, where older data are less important. The weights will be assigned to each period based on experience and intuition. The weighted moving average will equal to the weight for period n multiplied by the demand in period n, and we sum all those, divided by the sum of weights. The same example that was addressed before, if we assume that weights apply to this type of data, and that recent months will have the most weight, which is the weight of 3, while the one before will have the weight of 2, and the one before will have weight of 1. Then the summation of the weights will be 6. Using the equation of the weighted moving average, it will be the sum of 3 multiplied by 13, and this is the most weighted one, the recent one, plus 2 multiplied by 12, plus 10 multiplied by 1, and then we divide all by 6, and that will equal to 12 and 1/6. So with 12 and 1/6, we're closer to the actual, which is 16, from the moving average approach. And this is the idea. The idea is to get closer as much as possible to the actual. You can look at September here once we again do all of them, and you can see the actual are and the forecasted are almost the same, like 28 and 27.5, almost the same. Both simple and weighted moving averages are affected or effective in smoothing out sudden fluctuations in the demand pattern, but they have potential issues. If we increased n, will smooth the forecast, but makes it less sensitive to changes. Moving average does not forecast trends well, and it requires extensive historical data to be accurate. This graphs compared moving average and the weighted moving average with the actual sales. Weighted moving average predicts closer to the actual, but not with a lot of difference than the moving average. The exponential smoothing is a form of weighted moving average where weights decline exponentially and the most recent data weighted the most. This method requires a smoothing constant called alpha that ranges from 0 to 1. This constant will be subjectively chosen. The exponential smoothing does not require a lot of past data or record keeping. The forecast using the exponential smoothing method can be calculated by adding the last period's forecast to alpha multiplied by the difference between last period's forecast and last period's actual demand, where f of t is equal the new forecast, f of t minus 1 is the previous period's forecast, alpha is the smoothing factor or constant, which will be between 0 and 1, and t of minus 1 is the previous period's actual demand. The example in this slide assumed that Ford company was trying to predict the market demand for Ford Mustang. The predicted demand equal 142 Ford Mustangs. The actual demand 153. Smoothing constant alpha was zero point 0.2. Substituting the values in the exponential smoothing formula, the new forecast will equal to 142 plus zero point 0.2 multiplied by 153 minus 142. That is 142 plus 2.2, which will equal to 144.2 or around 144 cars. The smoothing constant will generally be between 0.05 and zero point 0.5, and as alpha increases, older values become less significant as given in the table. Giving less weight to older values by increasing alpha will get the forecasted values closer to the actual as shown in this figure, which means we choose high values of alpha when underlying average is likely to change, and we choose low values of alpha when underlying averages is stable. So the objective of these methods is to obtain the most accurate forecast no matter what technique we are using. Forecast error will equal to the actual minus the forecasted, actual demand minus forecasted demand. So it will be AT minus FT. So when we choose alpha, we should take this into consideration. We generally do this by selecting the model that gives us the lowest forecast error according to one of the three preferred measures. So we need to select the model based on these measures. The measures that we can use are the mean absolute division, which is the MAD, mean squared error, which is MSE, and the mean absolute percent error, or MAPE, or MAPE. The first measure is using the mean absolute deviation, which is equal to the summation of the absolute value of the difference between the actual and the forecasted divided by the number of periods n. The example in this slide shows the exponential smoothing forecast with alpha equal to 0.1 and with alpha equal to 0.5. Taking the absolute value of the actual minus the forecasted for both alphas, then finding the sum of all these values and dividing by n, we can get the mean absolute deviation. With alpha equal 0.1, the mean absolute deviation is 10.31, while for alpha equal 0.5 is 12.33, which means the error is less with alpha equal to 0.1, so this value will be preferred from the 0.5 and the alpha equal to 0.5. The second measure of error for the forecast is the mean squared error, MSE, which will equal the summation of forecast errors squared divided by number of periods. Going back to the previous example, squaring the errors as shown in the last column here, finding the sum of all these errors, then dividing by the number of periods n, we will get 190.8 for alpha equal to 0.1. If we calculate the one for alpha equal to 0.5, we will find that MSE is equal to 195.20, which confirms that using alpha as 0.1 is better since it has lower MSE, which is the same conclusion we had using MAD. The MAD MSE values depends on the magnitude of the item being forecasted. So if it's in thousands or in millions, the MAD and MSE will be very large. This problem can be avoided by using the MAPE, or the mean absolute percent error, which is equal to 100 multiplied by the summation of the actual minus forecasted divided by the actual, all divided by n. Back to our example, and with alpha equal to 0.1, the percent error will equal to 44.75. Dividing that by n equal 8, we get 5.59%. If we calculated the mean absolute percent error with alpha equal to 0.5, it will be 6.75, which again confirms that it's better to use the forecasted data using alpha as zero point 0.1. So that will be all for this session. If you have any questions, you can use any of the channels to email me or to discuss it with me. Thank you and have a great day.